In today's video, we're going to be discussing the method of substitution. This is another way that we can solve linear systems. In our previous video, we looked at graphing, so now we're going to dive into substitution. Here are the learning goals for today. By the end of this video, you should be able to rearrange linear equations to obtain expressions for x or y. And you should be able to solve a linear system, which means find the point of intersection, by substitution. We've only got one key term for today, which is method of substitution, and it means solving a linear system by substituting for one variable from one equation into another equation. Okay, so when we're rearranging linear equations to obtain expressions for x or y, you can choose which variable you want to rearrange and isolate for. So let's see an example over here. I'm going to put in this question right here. So let's just focus on rearranging. When we rearrange, we're trying to isolate for one of the variables here. Personally, I like to rearrange my equations so that they're in the y equals mx plus b form. It's just comfortable for me, but the way that you go about it is just going to determine how you solve the system. For example, if I solve for y first and you solve for x first, our steps might look a little bit different, but we'll come to the same conclusion. So let's rewrite this one right here. So I know if I want y on its own, it'll be positive, and x is going to be brought to the other side, so it's going to turn to negative x plus 8. And we can also try and rearrange this one too. Why not? Okay, so it's negative y equals negative x plus 4. And I know that to get rid of the negative, you can multiply or divide both sides by negative 1. I'm just going to multiply. That's going to get this positive, and maybe a negative 4. So that's how you rearrange your linear equations to obtain an expression for y. You can see that for both of them, I was obtaining for y. So you can do the same thing for x. It's up to you. Now let's use this same question, but let's start with our second learning goal now. Let's actually find the point of intersection of these two lines. So we're going to go back, and I'm going to rearrange the first one again. So we've got x plus y equals 8. So if I rearrange this, I get y equals negative x plus 8. Now what this has done is given me a value for y, which means I can take this information, and with my second equation, I can actually substitute this information in here to solve for x. So what that's going to look like is x minus negative x plus 8 equals 4. And now we're just going to simplify and solve. So that's going to be x plus x minus 8, right? Because there's a negative 1 here. And that equals 4. If you want to further organize it, you can do it this way. Some people like to do this part in their head. It's up to you. I'm just going to show you all my steps. Never hurts to show all your work. And we want to isolate for x. So we're going to divide by 2. That means x equals 6. Now that we've solved for x, we can take this new information and substitute it back into the original linear equation from the beginning of the problem. So I'm going to write it again down here. X plus y equals 8. Let's substitute that in. It's going to be 6 plus y equals 8. Y equals 8 minus 6. And then y equals 2. So therefore, to answer this question, the point of intersection of these two lines is going to be 6, that's my x value, and 2. And you can always do a check by substituting both values into the original equations, and you can get left side equals right side, then you know you did it correctly. Let's do another one. So here it says, find the solution to the linear system. Now do you remember what that means? It means to find the point of intersection. So they've given us two equations of two lines here, and neither of them are written so that one variable is standing on its own. So I want to rewrite it into y equals mx plus b, because that is how I like to do it. So I'm going to use the first equation because it looks the simplest, which is x plus y equals 5, and I'm going to rewrite this to isolate for y. You can do y equals negative x plus 5. Now what I can do is, into my second equation, I can substitute this information to solve for x. So what that's going to look like is 3x minus negative x plus 5 equals 7. Now we can simplify and solve. Okay, so we've got 3x. Remember there's a negative 1 here, right? So that's going to turn into plus x minus 5 equals 7. So I'm going to have 3x plus x equals 7 plus 5. That's going to give me 4x equals 12. Now we need to isolate, so I'm going to divide both sides by 4 so I can get x by itself. X equals 3. Okay, now I can take this new information and substitute it into the original equation over here. So I'll rewrite it down here. X plus y equals 5. Well, I know x equals 3, so it's going to be 3 plus y equals 5. And when I isolate for y, I get this new equation, y equals 2. Feel free to do your left side equals right side check to make sure that your coordinate, which is your point of intersection, is correct. Now let's see if you can apply your knowledge of the method of substitution to a word problem. Now this word problem is going to require us to make some algebraic expressions based on the content in the question. Okay, so let's break it down. We should just jump right in with our let statements. So let's figure out which variables we're going to use. Let me grab a different color here. Let's use the pink. So I've got Samantha and I've got Adriana. Okay, Samantha works twice as many hours per week as Adriana. Together, they work a total of 39 hours in 1 week. How many hours do they work individually? So I'm going to say let S represent the number of hours Samantha works and then we will let A represent the number of hours Adriana works. So let's write an equation that has to do with Samantha in the first sentence here. So Samantha, she works twice as many hours per week as Adriana. So that means she's going to work 2 times what Adriana works. And if we look in the second sentence, it says together they work a total of 39 hours in 1 week. So that means the two of them work a total of 39 hours. Is anything jumping out at you here? Because you should be able to see that we have a value for S. S equals 2A. And we can use that information to solve this word problem. So let's just substitute it right in. S equals 2A, so that means 2A plus A equals 39. 2A plus A is 3A, which equals 39. And to isolate, let's divide both sides by 3. And we've got A equals 13. So right now, I know that Adriana works 13 hours. We can use this information now to substitute into the original expression here. S equals 2 times 13, S 26. Okay? And then a way we can check this is substituting both of these back into either of these. The simplest one would be 26 plus 13. Does it equal 39? Right? Left side equals right side, so we know it's correct. Oh, that got cut off at the bottom there. Let's see. I'll write it over here. We'll just continue it along the bottom, which is 39 equals 39. And we know that's left side equals right side. And of course, we need a statement at the end. Therefore, Samantha works 26 hours per week, and Adriana works 13 hours per week.